Your skin tells your heartbeat exactly how fast it should run. We often think regulation happens solely in our minds, a purely cognitive exercise of calming down. But what if that internal state, your heart rate variability, whether you are stressed or grounded, is being dictated by pressure against your arm? It is not just information flowing from the skin to the brain. The afferent signals traveling through specialized cutaneous mechanoceptors create an immediate feedback loop with central autonomic generators in our nervous system. This means specific kinds of touch provide a physical lever, allowing us to dial up vagal tone and modulate sympathetic arousal without relying on sheer force of will. It shifts your baseline operating frequency, like turning a radio from static to clear reception. Sensation provides more than just input. It gives us reliable internal data streams about our body's status. When mechanoreceptors and proprioceptors send these precise signals to areas like the insular cortex, they build a sophisticated picture of what is happening internally. This heightened awareness allows us to refine our visceral interoception, the ability to accurately feel states like stress or deep calm. Studies confirm that specific pressure patterns enhance connectivity between sensory cortices and critical brainstem nuclei involved in autonomic stability. It means we are receiving high-resolution data on the body's current homeostatic set point. Real-time data is not just a snapshot of where you are right now. When peripheral feedback systems achieve this level of specificity, they fundamentally alter how the body processes perceived threat itself. We stop reacting purely on inherited reflex arcs. We start managing the internal state moment by moment. This fine-tuning allows us to stabilize autonomic function under enormous duress, building systemic resilience against overload. Yet even that adaptive capacity does not account for a deeper layer of control over emotional reactivity and stress endurance before it hits the cognitive center. What if this regulation is not merely about adapting when stress arrives, but predicting it? Signals gathered by mechanoreceptors do more than stabilize. They provide a predictive roadmap for autonomic function itself. We are talking about peripheral feedback looping back to the central pattern generators before your conscious brain even registers rising anxiety. Specific pattern touch input can actually preemptively shift sympathetic activation downward. This is not just calming down later. It is actively modulating baseline physiological readiness. Think of these cutaneous inputs not as a report, but as an early warning system tuning itself into calm frequency. The precision here means we could potentially calibrate this internal defense mechanism to mitigate emotional spikes before they even reach the prefrontal cortex. But what specific patterns trigger that critical predictive dampening? How does that predictive dampening actually work? It involves specific inputs hitting those mechanoreceptors in a highly organized way. The body is not just receiving random touch information. It is interpreting patterns like frequency or pressure oscillation. These controlled tactile rhythms act as an internal calibration signal to the central autonomic pattern generators. This process moves us beyond simple stress reduction and into allostasis, proactively maintaining stability by optimizing how fast your system can adjust when faced with inevitable disruption. We are learning that precise peripheral stimulation essentially tells the nervous system, stay balanced, before any cortisol has time to rise. It gives the body a preemptive tuning dial for its entire physiological resilience stack. But even this preemptive stabilization reveals an essential constraint on its efficacy. The dampening capacity we observed is not unconditional. Some data sets suggest the effect relies almost entirely upon flawless external pattern fidelity, meaning the input must be perfect. Other independent research suggests that the peripheral cue only registers if the underlying internal state already possesses a certain measure of autonomic plasticity. We are faced with two conflicting findings about where control resides. Is the nervous system responding purely to the specific cadence applied externally, or is it critically gated by our own physiological baseline? This tension complicates everything we thought we knew about immediate homeostatic repair. Ultimately, this intricate feedback loop suggests that control is not binary. It rests on calibration. The external signal acts like the dial knob, but your inherent physiological plasticity dictates how sharply that needle moves toward balance or chaos. If you are operating from an exhausted baseline state, no perfect cadence can overcome deep sympathetic load. But if you have built somatic resilience, that heightened insular accuracy we discussed earlier, then these peripheral inputs function as a true predictive dampener for stress reactions. The actionable takeaway is this: do not simply seek the right touch pattern. First, ensure your internal system has the capacity to receive it. Learn that foundational stability before chasing optimized performance. To see how specific patterns influence autonomic state in primary source detail, visit jmthomasofficial.com and consult the full research archive. Understanding this entire feedback architecture shifts control away from abstract mental effort toward embodied capacity. This is why the true mastery is not executing perfect rhythmic touch. It is cultivating internal resilience first. If your nervous system lacks foundational stability, external cues simply lack purchase against deep physiological load. Therefore, the ultimate actionable shift we can make right now is to stop chasing peak performance and start building homeostatic infrastructure beneath it all. This process moves us from reaction management toward predictive health maintenance across our entire physiology. To see how these specific patterned inputs influence autonomic state in primary source detail, visit jmthomasofficial.com and consult the full research archive.